Okay, so in this problem, we're finding points in the parabola that are closest to this particular point. So let's get a quick sense of what this looks like. So if I have a parabola, and it's going to look something like this, where it's this value 6 and it's upside down. It says closest to the point 0, 3. So here is the point 0, 3. And so somewhere here or here or here or here, somewhere along the line, I'm looking for the closest point. So there's a point here, xy, where the distance, which we'll call d, is a minimum. So I want to find the distance is a minimum. Well, my distance formula, what I know is a distance formula is equal to the square root of x minus 0 squared plus y minus 3 squared. And if you're not sure about this particular formula, it's in your formula booklet, and so you can just use that. Now, what I do know is that y is equal to 6 minus x squared. So d is equal to, and square root is just to the power 1/2, so this is x squared plus 6 minus x squared minus 3 squared to the 1/2, which is then, if I keep on going, I get x squared plus, simplifying this inside part, I have 3 minus x squared squared to the 1/2, which is then x squared plus, and I get 9 minus 6x squared plus x to the 4th all to the 1/2. And so now d as a function of x is equal to x to the power 4 minus 5x squared plus 9 to the 1/2. And so if I want to find a minimum, that means I have to go and find the derivative of the distance. Finding the derivative, the 1/2 comes down, times the inside part of my function plus 9 to the negative 1/2, subtracting 1, times the derivative of the inside, which is 4x cubed minus 10x. And so this is equal to 4x cubed minus 10x all over 2, that's this 2, to the x to the 4th minus 5x squared plus 9 to the positive 1/2. Now, if it's going to be a minimum, the derivative has to be 0. If the derivative is 0, I know that 4x cubed minus 10x is equal to 0. Solving this equation, I can factor out my x. And I have 4x squared minus 10 is 0. So x is 0, which, if I look at my graph, that doesn't make any sense. It could be this value here. If x is 0, it could be 0, 6. Or x could also be 4x squared, could be 10. So x squared is equal to 10 over 4, which is 5 over 2. So x is equal to plus or minus the square root of 5 over 2. And so I'm looking for, I'm looking at my sheet, and so this is plus or minus 1.58 if I put this into my calculator. And this is x equal to 0. Well, if I think about this diagram here, I can just see by the diagram, this here is a minimum, and that one there is a maximum. And so this is the maximum, and this is going to be the minimum. If I would go along and draw this out, or if I would graph the derivative, this derivative, I would see that it is indeed the case that this is a minimum and this is a maximum. And to be honest with you, you would have a calculator for this one. This would be a paper 2, so you would get a calculator, so you would be able to get this. You could also graph this on the calculator and see what you see and recognize that it is indeed, this one here is the minimum. And so if I want to find the minimum point, I then take the 1.58 and I am going to substitute it into D. When I do that, I get 1.66. And so that means when x is 1 plus or minus 1.58, the distance is 1.66 away from the point 0.3.